8.7 is called function notation. Here we're going to take a little bit of a change in our lessons, mostly to do with vocabulary words and terms. Function notation is when we take a slope-intercept form, like y equals x plus 2, and we change it, and it can be written as the function of x equals x plus 2. So if you notice in the equation, the function of x, or f with the parentheses x, replaces the y in our slope-intercept form. Okay, so it's read the function of x. It represents the value of f, or the function, at x. For instance, if we use what we just did up here, the function of 3, okay, is the function when x is 3. So the function of 3 would be 3 plus 2. The function of 3 would be, the answer would be 5. We're replacing the x value, kind of the input-output. We're replacing the x value with 3 and finding out what the output would be. So the function of x, the job when x is 3, is going to come out that the output would be 5. So let's do a couple of these for practice. The first one is, let the function of x equal negative 3x plus 8. Now it says, find the function of x when x is equal to 5. So first of all, I went ahead and I wrote it in the equation form. Now I'm going to replace x with 5. So the function of 5, what the work that 5 does when we're doing negative 3 times x, replacing that with a 5, plus 8. So what is the work of this 5? So we have negative 15 plus 8. Our answer is negative 7. So the function of x when x is 5, function of x would be negative 7. Let's try one more of those. So what about the function of x? And we're going to use the same sentence here again. Negative 3x plus 8, same expression. But this time it says find x when the function of x is for negative 22. So again, I'm going to substitute, but this time I'm going to substitute the negative 22 in for the function of x. So it's going to come over here. We're trying to find x. Okay, so the function of x, as we said, kind of replaces what we've been doing in slope-intercept as the y. So in slope-intercept, this would be y equals mx plus b. And so I went ahead and I replaced function of x. That's what equals the negative 22. When I do that, I'm going to say negative 22 equals 3x plus 8. Sorry, I don't know why that's there. Okay, we're going to subtract 8 from each side. So I'm going to get a negative 3x on this side. And I'm going to get, if I subtract 8 from this side, I'm going to get a negative 30. Sorry, that's a little sloppy. So I subtracted 8 from both sides. I get over here negative 30, and I get here my negative 3x. I don't want to know negative 3x's, so I divide both sides by negative 3. So my x is going to equal 10. So when function x is equal to negative 22, so that's kind of like when y is equal to 22, then x, we solved for x was equal to 10. So two different ways to say that, okay? One, they were telling me when x equaled a number, then I replace x with that number, and I solve for the function of it, or y. And the other one, they told me when the function of x. So that's like saying the y, the output's going to be negative 22. Now that we have some familiarity with the setup of the sentence, we can go ahead and move to graphing. Again, remember what you learned in slope-intercept form. So function of x equals 3/4 x plus 1. First thing we're going to do is rewrite it in slope-intercept form. So we're going to replace the function of x, which is our output, with y, and then rewrite the rest of the sentence. So now we can do the graphing the same as we did in the previous lesson. We're going to start with b, the beginning, y equals mx plus b, so that's 1. My y-intercept is 1. That means I'm not going anywhere on my x-axis. There's the 0. But I'm going to rise up 1. 0, 1. I look for the coefficient of x. That's 3/4. That's going to be my slope. So as I'm at 0, 1, I'm going to rise up 3, and I'm going to run to the right 4, okay, because they were both positives. So putting that on our graph here, the first thing we did was we wrote it into slope-intercept. Always start at the beginning. The beginning is 1, so let's go ahead and put our y-intercept at 1. That means it's going to go on the y-axis at 1. It doesn't move on the x-axis at all, so that is 0, 1. And you should always label your points, remember. So this one is 0, 1. Move on the x-axis 0, move up on the y-axis 1. All right. The next thing we're going to do is we're going to go ahead and we're going to do our slope. So I'm going to rise, and it tells me rise 3. So 1, 2, let's stretch this to 3. And it's a positive, so I went upwards. And then run, which is also a positive. I go from that point. I'm going to run 1, 2, 3, 4. So my next point is going to be there. My slope was rise 3, run 4. And then I would go ahead and I would put my line, because this is a linear equation, so that it would run through those 2 points. Let's go ahead and get rid of our rise and run, and that would be the graph of that line. And we did not label this one. Let's label it 1, 2, 3, 4 over. That's my x. And I'm going to go up 1, 2, 3, 4. 4, 4 is that point. All right. I am going to pause this before I start example 3. I don't know that we'll fit all this on one recording. Example 3, this time we're going to write a function without using a graph. So we're going to have to write a linear function, and the function is going to be the function g, given that the function g is 0 equals 9, and the function of g that is 3 equals -6. Again, we're going to want to look at these, and we're going to put them into coordinate points. So the function of something is the x, and the output is the y. Same thing over here. The function of that number, or the function of x, is going to give me this output, y. When I replace 3 into the x, I would end up with -6 as my output. This one gets people confused. It seems a little backwards. So find the slope of the function's graph from the values of g of 0 and g of 3. Now you'll also notice instead of the f for function, we have an italicized g. Anytime you see an italic variable and a parentheses, it means that you're speaking of a function. So you know that the graph of g passes through the points 0, 9, that was my x and y, and 3, -6. So first of all, we can go ahead and calculate the slope. I'm going to go to my y2, -6, and I'm going to subtract 9, find the difference of the y's. I'll also then go and divide that by x2, the second point's x, which is 3, and I'm going to subtract 0 from that. So -6 minus 9, or combined with a -9, gives me -15. 3 minus 0 gives me 3. I simplify that, and I now have my coefficient to x, or my slope, as -5. Now again, this is the same as working with slope-intercept, so we need to find the y-intercept. The y-intercept is given to us when we have an x that is equal to 0. So if the graph passes through 0, 9, I don't move at all on my x-axis, and I move 9, I rise 9, so my y-intercept, or b, is going to equal 9. So I put in my slope-intercept, I put in my slope and my intercept information. So the equation of the form g of x would equal negative 5x, that's our slope, plus 9, that's our y-intercept. Okay, again, the function replaces y, or the output. Otherwise, it's the same form of mx plus b, slope x plus y-intercept. Now we have to look at using it in real life. So we're going to have a story problem. In 2001, a scientific balloon was launched near McMurdo Station in Antarctica. So we're going to use function notation again to describe the balloon's altitude as a function of time. Again, this goes back to, you notice that I have rate underlined here. We're going to use the same way that we figured out slope-intercept. So after the balloon was launched, it rose at a rate of 500 feet per minute. Rate is going to be our value for our slope. Okay? We also learned then that the altitude, or the function of time, is going to be 500 t. Okay, we're using a little bit different variables here. Now, how long did it take the balloon to reach its final altitude? We know that its final altitude is going to be 120,000 feet. So we know the input, 500 t, is going to be, it's going to then have to get to 120,000. So 120,000 is equaling 500 t. To figure that out, we would go ahead and we would divide both sides by 500. So I will also do 500 over here. Didn't leave myself much room. So 120,000 divided by 500 gives me 240. Now we were talking about per minute up here, 500 per minute. So now I could go ahead and I could change my 240 minutes into hours by dividing by 6, and I would get 4 hours. So it's going to take me 4 hours to reach my final altitude of 120,000. I was moving at 500 feet per minute. There's where I get my rate, 500 plus t. Now, we didn't have a starting out point because we were starting out on the ground. So actually, my starting out point would be 0. It's not written in the story problem, but we're starting off on the ground, and we're going to rise up at 500 feet per minute. So we really didn't have a y-intercept there. And that would be what you would use, or how you would use function notation if we're talking about a real life situation that has to do with rate.